Hey, what's up, guys? Chung here again. So this time, let's take a look at another hard LeetCode problem here. Number 1444. Number of ways of cutting a pizza. Okay, so you're given like a 2D a pizza represented by a 2D matrix here, and and a matrix containing the following characters, either A or dot. So where A represents an apple and dot represents an empty cell. And you're also given like the integer k, where mm, where k represents you need to cut the pizza into k pieces, and the condition is that each piece needs to at least contain one apple. Basically, in order to cut the pizza into k pieces, you need to to uh, to make k minus ones cut, right? That's how you cut the pizza into k pieces, and it asks you to return all the ways of cutting the pizza such that each piece contains at least one apple. And since the answer is huge number, you need to do a modular of this big number here, right? Okay, so mm, for example, basically this is how the pizza will look like. So the example here is in this case the pizza is like 3 by 3 2D array here, and we have 4 apples, right, on the pizza. I don't know why there's an apple on the pizza. It's a weird pizza, but anyway, this is how the problem is defined as pizza as, right? Okay, so there are like 4 apples on this pizza, and it asks us to return all the possible ways, right? That we can cut this pizza into k pieces. In this case, there are like 3 ways. So the first way is to cut this one horizontally. Oh, sorry. And when you cut the pizza, right? If you cut the pizza horizontally, anything on the upside, right? On the upper side will be given to that person, and all we have left is the lower part. Same thing for the if we cut the pizza horizontally, for example, in this case, and the left part will be removed, and all we have left is the rest part here. All right. So basically, that's how this problem is telling us, right? And since we're getting it's asking us to get all the ways, right? All the possible ways of cutting the pizza. So it shouldn't be that hard to realize that this is another DP problem, right? Because so basically we're gonna have like a DP state here, right? So for the DP problem, we always need to define a state of a DP. So in this case, it's gonna be the I and J, right? So the I, J, and K, right? So this I, J, K means starting from this index here, basically, right? So at the beginning, we start at 0, 0, and so this state means from I and J and K. K means like how many cuts we need to make, right? How many cuts left, all right? And this IJ means starting from I onward and J onward, right? Basically anything starting from here. The, that's the range of the pizza, right? Starting from I and J, and with this k cut left, right? How many pieces? How many ways we can cut this current range of pizza with k pieces, right? So that each piece will contain at least one one apple, right? So and so the uh, the essence of a DP problem is that like anytime, let's say we have a ij here, right? And starting here onward, I mean, we can do this from bottom up or top down, but I think for this problem, it's more intuitive to do it top down because basically we're following the event sequence here. Basically, we're doing one cut here, and then the rest will be let's say if we remove this upper piece here, if we remove this upper part, and then we'll be handling basically the rest to the sub problem here, starting at this position, right? And so with that, if we're doing like top down at each state, we just need to do we just need to like find all the possible ways, right, that we can divide this current state into sub problems, right? And in our case, it's the what's how many possible ways we can cut the current state, right? Basically, we can either cut it horizontally or vertically, right? And how many ways I mean we can cut? We have uh we have one we have a one, two, and three, right? Yeah, actually we only have two ways of cutting it here. So anyway, it's either one, two ways. Basically, we have this one, two, and three. That's the how we can cut this sub pizza horizontally, and vertically same thing. We can either cut it here or cut it here, right? Basically, we just need to summarize all the possible cuts, right? And of course, we have to check if this current cut is a valid one or not. I mean, if it's a valid one, then we accumulate all the cut answers to the current answer. And in the end, we simply return the answer, right? So now another problem for another like the key problem for this DP problem is the how we can efficiently calculate, how can we efficiently check if those after doing the cut, right? So if the left piece or the remaining piece have the have at least one apple, right? So for example here, if we do this cut, okay. Hmm. For example, if we do this cut right here, how can we efficiently get how many apples we have on the left part and how many apples left we on the right part? I mean, a brute force way is we can always do a for loop, but that would be so slow, right? Is there a better way of doing that? Yes. If you guys know the presum, right? But normally the presum is only 1D, right? So this it's a 1D array. But there's also another like a 2D presum. Basically that and so that presum is like it's 2D, it's like I and J. So this 2D presum means starting from I and J, that's starting from I and J, and let's say this is ij 1, right? How many apples how many apples do does this like range contain? Basically the I to the end and the J to the end. From I to here and the J also here. So what's the total apple we have? starting from here and to reach all the way to the bottom right corner, how many apples we have here. And so with this presum, with this 2D presums, we can easily get the two subtotals, right? So let's say we do a cut here. Let's see if we do a cut right here, okay? And so we have like how many? So basically we have this left part and this right part, right? So for the right part, we can simply use the coordinates of this one, right? To get from the presum to get how many, because that's how we define the presum, right? So this I and j here basically will immediately tell us how many apples left on the right side. And in terms of the left part, how can we calculate that, right? So it's easy, right? We just do a pre-sum to let's say for example this is 0 0, right? We just do a pre-sum 0 0 minus the pre-sum of this case of this coordinates, right? So it's easier to get, right? So to calculate this area, we just use the total total counts minus this area, and then the left will be the left part. Okay, so that's how we can efficiently check if any part has at least one apple. Okay, so so with that being said, okay, we have this presum 2D presums, and then we can easily try all the possible cuts with the current range starting from this I and j. Right, so okay, let's try to code these things up. So I'm gonna define a DP here, right? So the I, or we call it current I and current j and the k, right? Okay, and then so basically here I'm simply returning the DP from 0 0 and k minus 1. Okay, so 0 0 is easy to understand, right? Because we're starting from 0 0, because that's the whole pizza, right? Starting from 0 0. Why k minus 1? Because we're using this k to help us counting how many cuts we need to make. Since our target is to make k pieces, that's why we'll make k minus 1's cut. Okay. Okay, so that's that. Now, let's try to do this presum, the 2D presum, right? And let me get the length, those two lengths, right? Pizza n is the length of the pizza 0, right? So to calculate 2D presum here, we just need to initialize that. At the beginning, it's 0, right? So and so we'll be defining like n plus 1 for range n plus 1. Okay. Why is that? It's because since we're always going to look for the next one. So if we start from here, start from the last one, if we're trying to get the previous one, like from these two directions, will be out of the boundaries. That's why I'm making one more an element, one more line and one more column to one more row and one more column to make sure we won't be out of the boundary. And then since the definition of the presum is from the current place onward, right? So let's say we have this. Hmm. So let's say we are at this position. Okay. So let me try I in range. Since we're calculating from the last element, going up and left, so we need to traverse the element backward, which means n minus one minus one minus one, right? And then for the j, it's same. J in range n minus one and minus one. Okay. And now we have a dp sorry, not dp, sorry, presum I and j. So what's the presum of I and j? So let's say we are at this position I and j. So how can we calculate the total, right, of this position? Actually, this is another like sub dp problem, right? So this is like a you're right. So this is like another sub dp problem. It basically asks you to calculate the the values, right? The values at this position, at like the presum of a 2D problem. So the way we're calculating the 2D presum problem is basically we get the values total from this uh, from this area, right? So because from okay, so if you remember the way we're defining the DP problem is so at this position it stands for the total number area. Okay, I'll try to use another letter color here. So the DP for this, right? So it represents the total numbers in this area. Okay, and then how about the DP for this one? So the DP for this one is the total. It represents the total area. That's the total area, right? And if we are like summarizing everything with DP this one and this one, we get everything here, but we are double counting this area, right? And this area is this one. So this one will be representing the area of this. So basically the DP of this will be the total sum of this one. It's going to be the deep pre-sum. That's the I j minus one, right? Plus the pre-sum of sorry, it's j plus one. Okay, pre-sum of the I plus one j, right? That's the total of this. But since this like small array got counted twice, we also need to remove one, right? And then we do a pre-sum. We minus the pre-sum of what? I plus one and j plus one, right? That's the total area of that. But we also don't forget to also add our current count. So what's the current count? Basically, it's easy, right? So it's one if the pizza is if the current cell is an apple, right? I j is a, right? Else 0. Okay, cool. Basic. So see, that's how we do the pre-calculate the sums at each I and j. How many apples in that area. Okay, cool. So with that, we can implement our main DP function here. So like always, we'll have like memorizations, right, to store the state. And if current I and current J and K is in the mem, okay, then we simply return the mem. So this is like a template, right? So that's the top-down template, okay? And then we're gonna have answer equals to 0, and here somewhere we'll be returning the answer, and then in the end we set the answer to the memorization, and then in the end we return the answer, okay? And now we have to do a for loop. Basically, we need to try all the cuts, okay? Hmm. Okay, so to try all the cuts, right? So where do we start? We start, okay, so let's try to try all the horizontal cuts. Okay. Basically for I in range current I to M, right? That's the all the horizontal ones, and then I'm gonna try J in range like current J to N, right? Okay. That's how I try each of the horizontal cut and the vertical cut. Okay, so to try the horizontal cut, right? So what do we need to check? Basically, all we care for now is we need to know if after the cut, if the ones we are cutting out or the piece we're giving to another person have any apple. Okay, so how do we calculate that, right? Mm, 1, 2, and 3. Hmm. Okay. Well, actually, we should start from current I plus 1 and also this J plus 1 because we'll need the next coordinates to help us calculate the pieces we're cutting out. So basically now the pieces we're cutting out, the apple for the pieces we're cutting out will be the pre-sum, right? The pre-sum and the total will always be the current I and current J, right? That's our that's always going to be our total apple in this range, in this sub pizza, and we'll be using this one to minus the ones it's going to be I, right? It's I and current J because since we're cutting it horizontally, then so that's for example this is the part we are cutting out, right? And what's left, so basically that's what's left, right? This coordinate is what's left, and this coordinates it happens to be the I and current J, right? So basically we're checking if this thing is greater than 0, right? That means okay, that's a valid cut at least for this piece, and then how about the remaining piece? We don't care about that. Basically, that's how this DP problem works. As long as we have the solution for the current piece, we just throw everything to the sub problem to solve, and we don't care if the rest has any apple or anything, because we'll be using any the the condition the check here to handle those cases. basically here all we need to do is we just do a calculate, right, with the with the dp, and so because the rest part will be the I current j, right, and then the cut will be we need to do a k minus 1. Okay, yeah, yeah, and okay, we'll implement. So basically, this for okay, I'll finish implementing this one as well. Basically, for to cut it vertically, it's similar, right? Oh, still we also need to use the total count, the apple count, right? Minus in this case, it's perpendicular, right? Because when we do a vertical cut, the I will be the same, but in this case, the J, right? The J will be sorry, current I. Current I is the same, and the J will be different. Okay, so answer plus dp and current I and j and also k minus 1. Okay, so that's how we do a cut. Now it comes down. It's time for us to define some base cases, right? Mm, so what's gonna be our base case? So first, I mean, I think one of the base cases, if k is equal to 0, right? So if the k is to 0, which means we have already made all the cuts, and it's time for us to return a 1 here. Mm, yes. So in this case, we don't need to check if the current I or current j uh, has any apple or not, because we already made k minus 1 cuts, and every time when we made a cut, we check if this current piece we're cutting out has apple or not. And so here all we need to check is if we have any k equals to 0 cases, because we already know we already have like k minus 1 cuts whose apple is greater than 0. So that's why we can simply return like a 1 here. And another case is the if basically for those cases which k is not equals to 0, what we need to check, right? So we have to check if the current pizza has any apple or not, right? So the current sub pizza, we simply do a pre-sum current I and current j. If this one is equal to 0, right? We simply return 0. So this one means for the sub pizza, if there's no apple at all, right? Which means there won't be any valid cuts in this case. So we simply return 0. Mm, yeah, and in the end, we simply return this dp. Okay, yeah, I think I also need to do a modular of that 10 to the power of 9 plus 7, right? I think that's the thing we need to do a modular here. Yeah, I think that should pretty much it is. Okay, let's try to run it. Mm. Oh, here we're missing a equal sign there. 3 and 6 and 3. Um, I think I know what's the issue here, because I think when we do the check here, the sequence of the check also matters. So we basically we need to check if the current range is zero or not. If it's zero, we return zero. Otherwise, we check k. Why is that, right? So if we check k's first without checking the current sub pizza, if the current sub pizza has any apple, this one may not be always the true, because let's say we're making like a cuts here, right? So the cuts will be starting from here. Basically, we're making three cuts here. Is it two, three, zero? Are we making? I think we're making like if it's zero, this is zero, m is three. So zero, one, and two. Okay, so we're making two cuts, right? Okay, we're making two cuts. We're making the first one is one, second one is two, and let's say we're making two cuts. The second one is here, right? So once we're making after we making second cuts, the uh, the k will become zero. So yeah, right. So the k will become to zero, because k in this case uh, is in this case two, right? Since we're going to cut it into three pieces, we will be making two cuts, right? And that's why at the beginning this is two. So after making two cuts already, this k will be zero. So the next time where the last for loop is this sub pizza, right? And this last loop is sub pizza, and we have the k is zero in this case. Is it zero? Yeah, so I think I didn't explain this part very clearly. So basically after k minus 1 is cut, in this case, right? So the first cut, we got this piece out. We got the first row out, right? And with the second cut, we got the second row out. And when the k equals to 0, we have this sub pizza left. And in order for us to return a valid 1 here, so when k equals to 0, the current sub pizza has to have at least one apple to make the last piece a valid one, right? I think here and right, so basically if the pre-sum of the current one, so maybe I think this might be a better way to understand it, and it's greater than 0, else okay, mm, if right, else mm, I think this should work. When k is equal to 0, we simply do yeah, we simply check this. I think this should work. Yeah, let's try to run it. Yeah, and actually, so we can even stop it a bit earlier. like I said, I mean, we don't have to stop when the k is to 0, right? We can simply do a like what we did before. We can stop as early as when the when this current when this current I and current k has nothing. If this thing is 0, right? Basically, we simply return 0 because we know there's nothing left in this current sub pizza. Then there won't be any valid cuts here, right? And then next, when this k equals to 0, we know because at this moment we already check if this thing has a pizza or not, has a apple or not, and we can just simply return a 1 here. So this should just work. And as you can see, this is a bit faster than the previous one because we might end up at current at this branch earlier instead of going through all the cuts here, right? Because if this thing is like if this is 0, and when we do this cut here, when we do this for loop here, this if statement will always be 0, right? Because we know anything, there's no apple from this point onward. So this two if statement will always be 0. That's why when we use this thing, the if check here, we can end some branches much earlier. And yeah, I think that's it for this problem. Yeah, it's very interesting DP problem. You know, the tricky part. Okay, let's do a quick recap here. Oh, how about the time complexity here, right? So the time complexity is the so how many sub problems we have here? We have we have rows. We have rows. Basically, that's the rows. So for DP problem, the time complexity is the rows times columns, right? Times k in this case, right? That's the number of the sub problems. And inside of each sub problems, we also do a for loop here. And the for loop is gonna be this one. So either m or n. So basically, if the n is like the biggest one of the rows and columns, so it's gonna be n times k times another n, right? Basically, n to the power of 3 and times k. Okay, and yeah, so here it's like just like a pre-calculation. Here is like O of n squared, but since we have this bigger O of n, so the time complexity is going to be uh, n to the power of 3 times k, and the space complexity is this one, the mammal, right? Which basically that's the space going to be the n square of k, right? So that's the space complexity. Yeah, so for this DPU problem, I think it's not that difficult to come up with the how we can uh, cut the current I and J to the sub problems, right? I think this part is not that hard. Basically, we just try all the horizontal cuts and vertical cuts, right? The cuts. The tricky part for this problem is how can we efficiently check like how many apples, right, within each pieces. And the idea here is that we use a 2D pre-sum technique here, so that we can easily get those the apple counts for each of the segments. And also maybe a few small tricks on the small things we need to be careful when we do this boundary check here. So like when should we return a one, and when the case to zero, should we return one? We also need to check if the current I and j has has a value, has an apple or not. Only we only return one if the current I and j has at least one apple, and also case is to zero, is equal to zero, and then we return one. Otherwise, we return zero. Mm, yeah. So next time when you guys see a DP problem, try to define like the state first, right? So I think in this case the state is quite obvious because after we divide this thing, the left will it's clearly will become a sub problem, right? And then the next step, once you have the state, and then the next step will be how you can, since in this problem it's asking us to get all the counts. So that's why we are doing for all of the possible cuts here, we get uh, we summarize them together. And for all the other problems, many cases, the problem will either ask us to calculate the maximum or the minimum value. So in that case, instead of summarize everything together, we do a minimum or max with the current answer, right? And yeah, and once we have all the possible scenarios here, we simply try all the possible scenarios, and we finish not calculating, we finish checking the current piece. We make sure the current piece is valid, and then we just pass the remaining part to the sub problem to calculate. Yeah. Mm, cool, guys. I think that's pretty much I want to talk about for this DP problem. I'm gonna give it my own upvotes. I think it's a great problem. And cool. Thank you so much for you guys to watch the videos, and stay tuned. See you guys soon. Bye bye.